Question 4. Table 4.1 gives enthalpy change of hydration of the three ions, fluoride, potassium and calcium ion. Okay, this is their value. And A part 1. Define enthalpy change of hydration. Okay, very easy. You must start from gaseous ion. Enthalpy change when 1 mole of gaseous ion dissolve in the sufficient amount of water to form a very dilute solution. Okay, that's the definition for hydration. It must be 1 mole of gaseous ions dissolved in the water. Part 2. Explain the relative magnitudes of the enthalpy change of hydrations of the potassium and calcium. These two. Potassium and calcium, actually they are neighbor next to each other. This one is group 1, this is group 2. So why the hydration enthalpy are so much different? It's because the size and the charge. The size of the calcium ion is actually relatively smaller compared to potassium, and it has a 2 positive charge. So first, you need to explain this one is more exo, this one is less exo. Okay, the hydration enthalpy of the calcium ion is more exo than the potassium. Okay, because this calcium ion has a smaller ionic radius. I told you just now, because it has more proton, and the size is smaller. And of course, it has 2 positive charge. So eventually, the charge density of this calcium ion is greater. So it has a stronger ion dipole attractions with water. Remember, the attractions between the ions and the water, because water is only dipole, partial positive, negative. So the partial negative side means the oxygens here. It will form the ions dipole bond with the calcium ion. So that's we call ion dipole, means ion is in this case is calcium, dipole means the water. They have attraction when the gaseous ion dissolve in water. Okay, part 3. Define lattice energy. The energy change when gaseous ions come together. Lattice energy is always the reactions between the gaseous ion, the gaseous cation and anion. Okay, eventually they will form 1 mole of ionic solid. So that's the things you must put. Gaseous ions that form 1 mole of ionic solid under standard condition. Okay, part 4. The lattice energy of calcium fluoride is a negative 2602 kJ per mole. Calculate the enthalpy change of solutions in kJ per mole of calcium fluoride. If you want to make it fast, then you just if possible, you just memorize this equation. Enthalpy change of solution, it must be the hydration enthalpy minus the lattice energy. Then you need to find the hydration enthalpy here. So it's here. So calcium ion and the fluoride. So you just substitute these 2 values into this equation. Just remember, calcium is 1 mole, fluoride is 2 mole. So it need to times 2. And the lattice energy is given here, negative 2602. So eventually, enthalpy change of solution, you get negative 60 kilojoule per mole. Okay, part B. The formation of the calcium fluoride at 298 Kelvin is shown. So enthalpy is given, Gibbs is given, all in kilojoule per mole. Calculate the entropy change, the delta S, in joule per Kelvin per mole for this reaction. Then you need to use the Gibbs equation here. So delta G equal to delta H minus T delta S. Substitutes the 2 enthalpies into the equation. So negative 1162, and enthalpy is negative 1214. Okay, minus the temperature is 298 Kelvin. You just use 298 times the delta S. Okay, so if you want to get the answer nicely, So you need to make sure the 298 the Kelvin times delta S over 1000, because the Gibbs equation, this Gibbs is kilojoule per mole, this one is kilojoule per mole. So the entropy here, if you need to use in the Gibbs equation, then the delta S need to be like over 1000, right, times the temperature. Then rearrange, you get the delta S is actually negative 174.5 joule per Kelvin per mole. Okay, that's the normal calculation for this the Gibbs equation. Okay, thank you.